Hello everyone. Following the success we had with our previous GUI, known as BeamSolver, and all the great reviews we received from our fans and followers, we have developed another interface, known as BeamSolver. And BeamSolver solves for deflection of a statically determinate beam and determines the minimum cross-section of lumber that meets the deflection criteria of length of the beam over 360. It will also calculate and plot the shear and moment that the loading creates on the beam. Now let's look at the manual inputs that are required in the GUI to perform the calculations. The default values are already provided within the boxes, and for the purpose of the presentation we will leave those values alone to start off with. The beam length is 100, the number of nodes are 101, and to improve the accuracy of the calculations, you can increase the number of nodes. We will only have one distributed load and 2-point loads for this demonstration. And you can change the start and end location of the distributed loads and change the location that each point load is loaded on the beam. You can also add a tensile force, and for the purpose of this presentation we'll leave that at 0 for now. And to run the calculations, you have to either click Simply Supported or Cantilever, depending on which analysis you're looking for and the conditions of your beam. So for the first part we will use Simply Supported to produce the plots and bring up the calculations we're looking for. As you can see here, a message box pops up with the maximum shear and max bending produced on the beam. This pops up every time you perform the calculation. We press OK to view all of the figures that are produced. The first figure shows the location of the loading of the 2-point loads and the distributed load right here. And in the simply supported case, it shows 2 pins, which also represents a roller in a pin or any other simply supported case. Just for the purpose of keeping it simple, we have shown 2 pins for all simply supported cases. In the second diagram, you can see in red the deflection of the beam. And this is a bit exaggerated. However, you can refer to the values on the y-axis to get the actual value of the deflection. The next 2 figures show the shear and moment, the shear diagram and the moment diagram for the loading case. And to view the minimum cross-section that is allowed for the lumber to meet the deflection criteria, we click best cross-section. And you can see the dimensions are 4 by 6 for this particular load case. Now to run another case, we have to click the reset button and run the code. Now if let's say we want to run the analysis on a case in which the load is outside the length of the beam, you will see what happens. You'll see a message box pop up showing that your load location is outside the beam, and an error will pop up and you will not be able to run it. This also occurs, let's say our point load is outside the beam. You'll get another pop-up showing that the point load location must be within the beam. So if you do enter incorrect values, there are parameters set to notify you of that. And another option here is the browse button on the bottom, which allows you to input unlimited load cases. Thank you very much for viewing our BeamSolver tutorial, and I hope you give it a shot.